In today's video, we're going to look at graphing trigonometric functions, and we're going to focus on the sine graph and the cosine graph. This one's a pretty intense video because you're going to learn all the transformations of the trig functions, and then in later videos we're going to move on to the other 6 trig functions. So we have some new terminology that you'll need to focus on as we go through this lesson. One thing is the midline of the graph, the amplitude, the period, the phase shift, the vertical shift, the reflection, and then of course you should already know domain and range. And we're going to be able to look at the equation of the function and determine these key characteristics of the graph and use it to draw the cosine or sine function, sketch its graph by hand. This is no calculator involved. And then you're also going to be, by looking at the graph or key characteristics of the graph, you're going to be able to find the equation. So we're going to go the other direction as well. So first we need to know our parent functions, our simplest sine graph and our simplest cosine graph. So we're going to look at y equals sine of x. That's going to be our simplest sine graph, which is our parent function for the sine function. Now to do this, I'm going to go back to my unit circle, and I'm going to recall that my quadrantal angles at 0 radians, I'm at 1, 0. At pi over 2, we're at 0, 1. At pi, we're at negative 1, 0. And at 3 pi over 2, we are at 0, negative 1. And also recall that the sine is your y values. So these are my function values at those angles. So to sketch our graph, first thing we have to do is you're going to need to be able to label your tick marks on your graph. So since I'm focusing on these quadrantal angles, I'm counting my 90 degrees, or always in radians. So I'm going to count by pi over 2. So I go pi over 2, then pi, then 3 pi over 2, and then 2 pi. And let's also go in the negative direction. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then you also need to label your y-axis. And I noticed all these values are between 0 and 1. So I need to go to at least negative 1 and 1. So I'm going to count by 1 on my y-axis. Okay. So at 0 radians, I have a height. My sine of 0 radians is equal to 0. That's from this number from the quadrantal angles. So I put a plot on the point 0, 0. At theta is equal to pi over 2. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is back to 0. So it's a nice wave curve that looks like this. Okay, that is one complete wave. So I start here at the x-axis. I go above the x-axis, back down to the x-axis, below the x-axis, and back to the x-axis. So that's one graph. Now let's go the other direction around this unit circle. So we're going to go this direction now. So at negative pi over 2, I'm at negative 1. When I go to pi, negative pi, I'm to 0. And negative 3 pi over 2, I'm back up to 1. And at negative 2 pi, back to 0. Okay, so this is the graph of y equals sine of x. So you will need to memorize that. Okay, next I'm going to look at the parent graph for y equals cosine of x. And so again, my quadrantal angles, I should have stated. Okay, so this is a point 1, 0. And this is 0, 1, negative 1, 0, and 0, negative 1. This time we're focusing on cosine, which is our x values at these quadrantal angles. Okay, so if I wanted to find my cosine of 0, that is at 1. Oh, didn't label my axes yet. So I'm counting by pi over 2. So I'll make each tick mark pi over 2. And the same thing in the negative direction. Yes, you have to label every graph with these values. Don't forget labeling your tick marks. All right. So my first angle here is at 0 degrees. I'm at a height of 1. Cosine of 0 degrees is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. So this is one period of the cosine graph. Now if I put in the other period, going the other direction over here. Okay, so at negative pi over 2, I'm at 0. Negative pi, I'm at negative 1. At negative 3 pi over 2, sorry, I'm at 0. And negative 2 pi, I'm up to 1. Now look, these graphs look very similar except for if I took this sine graph and I just moved everything over in this direction pi over 2, you would end up with the cosine graph. So these are very similar with just a small translation, a movement to the left, okay, or to the right, because if I took the cosine graph and moved this cosine graph every point right pi over 2, it would look just like the sine graph. So for that reason, I'll often specify, give me a sine function that fits this graph, or give me a cosine function that fits this graph. Because any of these wave curves like this, any sine or cosine graph, you can find two equations for it. You could find a sine equation and a cosine equation that matches it. So that's the reason why I usually will specify when you're given the graph which type of function I want you to write. All right, so this is the graph, the parent function y equals cosine of x. Now we're going to start talking about transformations of the graph. Now before we talk about transformations, we're going to focus on what our standard form or transformation form of the sine function and the cosine function is. So that's these two equations here. This is the transformation form. So the letters I'm going to use to describe different transformations, the A, the B, the C, or the D, is based on this form of the graph. So if it's not written in this form, you're going to have to do some algebra and rewrite it so that it matches up to this form as we're working. So the very first transformation that we're going to learn involves the constant factor, the absolute value of A. So it's this coefficient here that's multiplying by your trig function. And if it's negative, we disregard that. We're just looking at the absolute value, so we're just looking at the number itself when it's in this transformation form. This A determines the amplitude of the trigonometric function. Now, what is amplitude? Well, the amplitude is half the distance between your maximum and minimum values on your function. So, for example, here is a maximum on my cosine graph, and my minimum is down here, so it would be at this distance. So here I have a distance of 2. So if I take half of 2, that gives me 1. So my amplitude of my cosine graph is 1, which makes sense because the number I'm multiplying cosine by here is understood to be 1. So A in this problem is 1. So that's my amplitude. Another way to look at the amplitude, instead of going from that, is that the amplitude can also be figured out by as the distance from the minimum max values to what's called the midline. So this is a new term as well that we haven't learned yet. So I'll show this on the sine graph. All right, so the midline, which I'll highlight. You green here. The midline is the line through the middle of your sine and cosine graph, like this. So this point here is called the midline of this function. Likewise, the x-axis is also the midline of the parent function for cosine, so that's also my midline. Okay, now if I go from the midline to my maximum, I have a distance of 1, and that is equal to my amplitude. If I go from my midline to my minimum, that distance, again, we're dealing with this absolute value because we're dealing with distance, we don't do positive or negative. That distance is also 1. So in this case, my amplitude, A, is equal to 1. And you can see that because my function is understood to be 1 times sine of x. So A is 1 in this equation. All right, so in our first example here, we're going to find the amplitude of our function, and then we're going to graph the two complete periods. And I want to show you how I want to see the kind of graph. So again, amplitude is your A. So I notice the sine is being multiplied by 1/2. So that is my amplitude. My amplitude is 1/2. Now, when you're asked to graph these, what I want you to do is I'm going to always give you 3 graphs. On these first ones, we're not learning all the transformations yet. I only gave 2, but once we have all the transformations, you'll be given 3 graphs. On the first graph, you're going to always do your parent function. Okay, so I want to see the parent function, the very basic function. So for sine, that means my tick marks, again, are going to be pi over 2, pi, 3 pi over 2, 2 pi, same thing with the negatives. And I'm going to count by 1. Okay, and then this is the sine function. Here's a way for you to memorize this, okay? Let's choose another color. So sine starts on the midline, is above the midline, on the midline, below the midline, on the midline. On, above, on, below, on. Remember that pattern. On, above, on, below, on. That's for the sine function. So, to graph my parent function here of sine, I'm identifying my midline. So my midline is right through the middle here. I'm going to be on the midline, above the midline, on the midline, below the midline by 1, and on the midline. And that gives us what we call one full shape of the graph, and what we call that one full shape of the graph is the period of the graph. Okay, so all I want to see is this red graph here. So that's, and with all the graphs until your final graph, you can just do one period, and then the final graph you can draw the second period. So there is my parent graph. So this is y equals sine of x. So my next graph, I'm going to do my amplitude change. So again, this is pi over 2, pi, 3 pi over 2, 2 pi. You're going to get so used to writing these because you have to do them on every graph. And you'll see why I don't give it to you later on, and I make you write it. All right, so we have that information. So now I'm going to deal with our amplitude. So our amplitude of 1/2 says I need to go, my max and my min needs to be halfway and be half a distance, half a unit above or below my midline. And so, remember, my midline is here, and I start on my midline, and now I'm on my next tick mark, I'm above my midline, but this time I'm only above by 1/2. And then I'm on the midline and below the midline, on the midline. So notice it kind of makes it a lot thinner or squishes it together. That's what the amplitude is. It determines how high our peaks and valleys are in the graph. And so that's one period. So I asked for 2 complete periods, which means 2 complete pictures of that curve. So now I'm just going to do the same thing in the negatives. So I'm on. So I'm going backwards here. So I got to go below, on, above, on. So if I'm going starting at negative 2 pi, I'm on, above, on, below, on. That's one full period. And there's the graph of y equals 1/2 sine of x. And you've learned your first transformation with the sine function. Okay, now I'm going to go the other direction. We're going to find the amplitude of this graph. Okay, so I know it's kind of hard to read, so I'm going to kind of rewrite this. This line is 2, this is 4, this is 6, this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees is what those read. Okay, so first thing I want to look at is I'm going to figure out which trig function I think would be this one. Since we only know one transformation, we only have one choice. So I find my midline, and I notice that I started on the midline, above, on, below, on. Well, that sounds like the sine function. So this is going to be the sine function. Next thing I need to do is figure out my amplitude. Well, the amplitude is the distance from my midline to my maximum. In this case, is 4. So I know A has to equal 4 because amplitude is 4. So the equation I would write is y is equal to 4 sine of x. And there you have how you can find the equation from a graph. Now in our next example, it asks us to write the equation of the sine function that has an amplitude of 5. Well, y equals 5 sine of x. Done. Now you could have got fancy, and as you can see from that transformation form, I do have some other numbers that can be going in. So maybe you'd write 5 sine of 2x plus 2 or something like that. That would work as well. What I'll be focusing on is the key thing is your a value needed to be 5 and you needed the sine function. Okay, all 6 trigonometric functions that we'll be learning in this chapter are what we call periodic functions. In fact, the name of this unit is periodic functions. That is, the graphs of the trigonometric functions repeat periodically. For the functions y equals sine of x and y equals cosine x, the period is 2 pi, as we observe from these parent graphs. It took us from 0 degrees to pi over 2, so that's a period of 2 pi on the x-axis to go that full valley up, valley down shape. So on the midline, above, on, below, on. To get that full pattern, it takes us that long to do it. Same thing on the cosine graph. It has a period equal to 2 pi because it takes us from above, on, below, on, above. There's our pattern for the cosine graph. So they both have periods of 2 pi. But one transformation that we can do is changing the period of the function. And when we change the period of the function, that's going to affect, we're going to look at our transformation form of the graph again. This is our transformation form. And then the number that changes our period is the b. Okay, the b affects the period. That's not just the b, whatever the b is does in terms of period. How you actually calculate the period of your graph is you take the normal period for the parent function, which is 2 pi, and you divide by the absolute value of b. Again, we disregard any negative signs at this point. Those tell us a different transformation. All right. So we're going to find the amplitude and the period of each of these functions, and then graph 2 complete periods of the graph. So again, we're going to start by our amplitude. So that's A. So since A is 4, my amplitude is 4. Okay. And we are looking at a cosine graph. So I'm going to go ahead and put in my key. So this is pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And I need to go up to 4, so I'm going to count by 2, 4, 6, so it'll fit on this graph. So you can change the scale whatever you need to so that it fits. But I see that I'm eventually going to have to go up to 4, so I'm just going to do that scale. All right, so first we're going to sketch the parent graph. This is a cosine, so remember this starts above our midline, so our midline is here. If you want to, you can graph the midlines as a dashed line. Don't do a solid line because they're not actually part of the graph, so you can just do a dashed line. For cosine, we start above, and our parent function is an amplitude of 1. So above the midline by 1, on the midline, below the midline, on the midline, above the midline. And that gives us 1 period of the cosine x graph. So that's our parent function. Now, to do our transformation here, we're going to deal with the amplitude of 4, and now we got to learn how to deal with the period. So remember, our formula for period is 2 pi divided by the absolute value of b. So our period here is going to be 2 pi divided by, well, b is 3. So our period is 2 pi divided by 3. Now, figuring out what 2 pi divided by 3 is in this, if I count by these intervals here of pi over 2, pi, 3 pi over 2, and 2 pi, that's going to be kind of messy, and it gets really kind of confusing. You have to do a lot of fraction math in your head. So, and I still need to fit 2 full periods on this graph. So what I do is I change the numbers I'm counting the tick marks by so it fits my graph. And what you do that is you figure out what you need to count by for each tick mark. How much do you need to count up for each tick mark? And to figure out what you need to count by, give myself some more room here. To figure out what you need to count by on your graph is you take the period of the transformed graph and divide it by 4, because I have 1, 2, 3, 4 tick marks that I want to fit in here, and that gives me 1 full period is 4 tick marks. So I'm going to do that algebra here. So 2 pi over 3 divided by 4, so that's going to be 4 over 1. So I'm going to take that bottom fraction and I'm going to flip and multiply. I get 2 pi over 12, and then I can simplify that and I get pi over 6. So I'm going to count by pi over 6. So now that I know I'm counting by pi over 6, think of it like this. So I have these 4 tick marks here. I know this first one is my axis. It's going to be pi over 6. And then I'm going to count up one more pi over 6. That's 2 pi over 6, 3 pi over 6, and 4 pi over 6. But you know me. You can't leave it like that. You have to simplify your answers. So 2 pi over 6 simplifies down to pi over 3. 3 pi over 6 simplifies down to pi over 2. So I'm seeing in just this little piece here, from 0 to 2 pi, that's actually 3/4 of my entire period. So it's squishing the graph together. And if I take 4 pi over 6, that simplifies down to 2 pi over 3. Now this last number, if you did your math right, should equal your period of your graph, okay? So now I'm going to go down to my new graph. This is my final graph here. And I'm going to label this first tick mark pi over 6. I'm counting by pi over 6. And then 2 pi over 6 simplifies down to pi over 3. 3 pi over 6 simplify down to pi over 2. And 4 pi over 6 simplify down to 2 pi over 3. And then the same numbers in the negative direction. So now you know why I didn't label the axes for you, because you're going to be changing them quite often. And again, I'm going to keep counting by 2 on my y-axis. Oops, that is a 4. Okay. So now we're going to graph this final one. So I'm going to take this parent graph, change my amplitude to 4. Now, since I changed my scales here of what I'm counting by, and I'm doing 1/4, I'm still going to stay with the same power. Above the midline, on the midline, below, on, above. So again, my midline is on the x-axis. So I'm going to do the amplitude above, on the midline, amplitude below, on the midline, amplitude above. And now, because I changed my scale, that's it. I've sketched one full period. So let's go in the other direction. I'm above, so I need to be on, and then below, on, and then end at above. And now you've sketched two full periods of our equation y equals 4 cosine of 3x. All right, let's do one more before we learn our new transformation. All right, so we're going to figure out the amplitude period and count by. Okay, I would pause the video and see if you can figure this one out by yourself, and then come back and watch me do it. All right, so amplitude is our A, which is a 3. So our amplitude is 3. Our period is equal to cosine's period is 2 pi, divided by the absolute value of b, which is 2. So that's going to be pi. All right, so for our parent function, let's get that. So I notice this is a cosine graph. Pi over 2, pi, 3 pi over 2, 2 pi. These don't change for the parent function. These are always, that's the reason you'll get so used to writing these. These quadrantial angles are always on our graph of our parent function. So our parent function for cosine is, again, my midline is here, is a 1 above, on the midline, 1 below, on the midline, 1 above. Okay, so that's y equals cosine of x graph. Okay, so now I have a period of pi, so I need to figure out what am I going to count by for this graph. So remember, to figure out what you're going to count by, you take your period of the transformed graph and divide by 4. So I'm going to count by pi over 4. So my first tick mark is pi over 4. My second tick mark is going to be 2 pi over 4, which is pi over 2. And then 3 pi over 4, which does not simplify down. And then 4 pi over 4, which is just pi. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. And then I'm going to look back on my amplitude was 3, so I can still count by 1. I just got to make sure it fits in my graph to change my y-axis if needed. All right, so now, I'm going to graph my amplitude and my period. I graph by changing the scale on the y-axis. So I'm just going to graph that amplitude. So remember, our midline is here on the x-axis. And so I'm going to start above the midline by the amplitude, so 3 above the midline, on the midline, below the midline, on the midline, above the midline. So there is one period of this cosine graph. Now do the other one. I'm above, so on, below, on, above the midline. And this is the graph of y equals 3 cosine of 2x. Okay, so now let's go in the other direction. We want to write a cosine function that has a period of pi over 4 and an amplitude of 1/3. So since I have an amplitude equal to 1/3, it tells me A is 1/3. Now I have to find B, so I'm going to use my formula. Period is equal to the parent function's period, which is 2 pi, divided by B, absolute value of B. And so the period I was given was pi over 4. That's equal to 2 pi over B. So multiplying both sides of the equation by B, and then dividing by pi over 4. So when you divide, you flip and multiply, and I end up with 8. So B is 8. So I go to my form y equals A cosine of bx, and my equation is y equals 1/3 cosine of 8x. There you go, finding the equation given that data. Okay, when a trigonometric function is shifted to the left or to the right, it has a special name. This is called the phase shift. Oops. Okay, the phase shift of a function in that standard form of y equals a sine of b, parentheses, x minus c, close parentheses, plus d, or the same thing with the cosine function, is determined by the value of c. Okay, c determines it. Now, if c is less than 0, the graph is shifted to the left. But this can be a little confusing because notice the formula is x minus c. So usually how I work through this is I do the equation x minus c equals 0 to get my phase shift. So I don't have to remember this plus or minus thing. And so if I do, if I do that x minus c there, and I get x is equal to positive c, okay, that's positive, so this is moving to the right, okay? But if I have something like x minus or plus c, set that equal to 0, you get x minus c, or you get a negative value. Well, that's kind of poorly thought out there how I did that. I'll show you in the example, it makes more sense. So the phase shift, if c is less than 0, but if you actually have, because you'll usually write x minus a negative c if c is negative, so I'm writing that as if c was negative, then you have x plus c. So you'll usually see it written like that. It means you have a shift to the left. That's what I was trying to say over there. Okay, and if c is greater than 0, then you're going to see x minus c. Okay, and then your shift to the right. Okay. Now we're going to keep building. So now we're going to identify the period, the amplitude, and the phase shift. We'll also have to identify what we're going to count by. Notice I don't require this. I grade that by what you put on your graph, but you will have to figure that out each time. And then we're going to sketch two full periods. Now for the first time, this function is not in transformation form. So this is the first one we have to do some algebra to make it look like. See, the key way I knew that this was not in transformation form is I noticed that the coefficient of x is not 1. The coefficient of x here is 2. So I have to rewrite so I can factor out that b. So what you do is inside the cosine function, I'm going to take that coefficient of the x, which is 2, and factor it out of everything inside the parentheses. So to do that, I'll just take each of the terms and divide by 2. So that gives me x. That negative pi over 2 divided by 2. Again, flip and multiply. That gives me negative pi over 4. So it's going to be minus pi over 4. Parentheses. So that is our transformation form of this function, and that helps us. Now we can easily identify our different transformations that we're going to focus on. So I'm going to be looking at this transformation form. So to find my period, remember that is the b value affects our period. So our period is going to be the standard period for cosine, which is 2 pi, over our b. So this is going to be a period of pi. Okay, to figure out what we count by, we take our period and divide by 4. So we're going to count by pi over 4 on everything but the parent graph. Parent graph, we count by the quadrantal angles. Our amplitude is determined by the coefficient that you're multiplying the trig function by, the absolute value of it. So our amplitude is 2/3. Okay. Now here is how I figure out my phase shift, because I see pi over 4 and I always had problems, remember, is that to the left or to the right? You do have to figure it out. So what makes sense to me is if I do this and set it equal to 0, just take what's inside those parentheses there, set it equal to 0 and solve, I get a positive value. So positive is the right, going to the right. So since the phase shift is pi over 4 to the right, would be our phase shift. All right, so sketching, start with our parent function. So that's pi over 2 pi, 3 pi over 2, 2 pi. Same thing with the negative. Count by 1. Okay, this is the cosine function. Okay, so I meant our midline is here on the x-axis. Cosine starts above by our amplitude, and for our parent function, the amplitude is 1. So above, on, below, on, above. So those are the dots that I'm going to be transforming. Next, I'm going to, counting by pi over 4. So my first tick mark is now pi over 4. 2 pi over 4, which gives us pi over 2. 3 pi over 4. And then 4 pi over 4 simplifies down to pi. Same thing with the negatives. And then I look at my amplitude. My amplitude is going to be 2/3. So I'm actually going to count by 1/3. Okay, so that'll be easier for me to graph. Now, this changing the scale down here, these count by things, that takes care of my period. So that's going to be automatically, I'm going to be able to sketch my period from that information. Okay, so I'm going to now, this is our middle, remember I gave you a work graph and a final graph. So in this work graph, I'm going to do my amplitude next. I usually stay my phase shift is usually my last thing I do. All right, so I'm doing the cosine graph. So our midline is at the x-axis. Good. Remember, you're drawing these as dashed lines. I guess I should draw one like that. So you would just put your midline like this as a dashed line. Okay, our amplitude is 2/3. So cosine starts above. So I'm going to be above by 2/3, on, below by 2/3, on, and above by 2/3. Okay, that's taking care of our amplitude and amplitude and our period. Okay, now on this same graph, I'm now going to sketch my, I can move on to the next one since it's my last one. Now we're going to sketch our phase shift. So let me label my values again. All right, so we're going to move each dot pi over 4 to the right. So if I'm counting by pi over 4, it's going to be one full dot over to the right is what we're going to do. So I'm looking at this previous graph, and up here I was at above my midline. So here's my midline again. In my last graph, I was at 0 degrees. I was up to 2/3. So I'm going to move to the right pi over 4 and put that dot. And then in my last graph, I was here. So I'm going to move that dot over pi over 4. And I'm going to repeat that for every dot. And this time I'm going to actually end over here. Okay, now was on. So now this is going to be and there is 2 full periods of this, whoops, kind of got curvy there at the end, of this cosine graph. So this is y equals 2/3 cosine of 2x minus pi over 2. Whew, okay. Write the equation of a sine function that has a period of 2 pi, so that's our normal period. So since our period of 2 pi did not change anything, that means b must be 1. Amplitude of 3, so amplitude of 3, and a phase shift to the left, pi over pi over 6. So our form of the sine function, we now have figured out the three letters A, B, and C. So I know A is 3, B is 1, C is left was negative, so minus a negative pi over 6. So that gives us the equation 3 sine of x plus pi over 6 in simplified form. And that's the equation that meets those characteristics. Okay, when a trig function is shifted up and down, the transformation is called a vertical shift. The vertical shift of a function in this transformation form is determined by d. So we look here to figure out our vertical shift. If d is greater than 0, the graph is shifted upwards. If d is less than 0, the graph is shifted downward. This will change your midline. So the equation of your midline is y equals d. So that's going to be the equation of our midline. All right, so let's try this one. So I'm going to start by, I'm looking at this as the cosine graph. So I'm going to do my parent function. Whoops. Okay, and so our parent function starts for cosine, and there's my midline. Above, on, below, on, above. So there's my cosine graph, y equals cosine of x. All right, so looking at this, I see that in order to get in the form I need, this would be y equals 3 cosine of x minus a negative pi over 6 minus 2. So my period, b is 1, so that's still 2 pi. My amplitude is a, so that's 3. My phase shift is at negative pi over 6, but we don't write negative pi over 6. The negative tells us the direction. So it's pi over 6 to the left. And then vertical shift is the d, which is negative 2. So that tells us that we are going down 2 units. And the equation of the midline is y equals d, so y equals negative 2. Now the order in which I like to graph these is I like to start by, of course, doing my tick marks to match my period. So my period is 2 pi divided by 4 is counted by pi over 2, so I haven't changed anything. And then I like to do everything but my phase shift. I always say my phase shift for last. All right, so I have an amplitude of 3. I got a shift down 2. So I need to get at least 5 distance. So I'm going to count by 2 on my Y scale. Now, what I do is I always graph my vertical shift first. And by doing this, I'm going to graph my midline. So my midline is negative 2. So my midline is down here at negative 2. This is taking care of my vertical shift, down 2. Labeling my tick marks took care of my period. So now I'm going to graph on this first graph my amplitude, which is 3. It's a cosine graph, so we start above. So I need to be above the midline by 3. Then on the midline, next tick mark, I'm below the midline by 3. Then back to on the midline, and then above the midline by 3. And this is one full period of that transformation. And then the last thing I'm going to do is the phase shift. Now the phase shift doesn't affect where the midline is, so I'm going to go ahead and put that back there. But remember, I'm going to the left pi over 6. I'm counting by pi over 2, so it's 90 degrees, and pi over 6 is 30 degrees. So one box pretty much is going to move to the left. So this point is going to move to the left 30 degrees. And then this point on the midline is now moved to the left 30 degrees. This point below the midline is moved to the left. This point on the midline, moved to the left. This point above the midline, moved to the left. And that gives us one full period of this graph. And then going back on the midline, below the midline, on the midline, above the midline. Okay, and that is your final graph here. So we see actually graph y equals 3 cosine of x plus pi over 6 minus 2. And now you know all the different transformations. Oh, wait, one more transformation to go. Reflection. This one is pretty easy. Okay. If your A value is negative, you have a reflection across the midline. If your B value is negative, you have a reflection across the y-axis. All right, so again, this is not in transformation form, so I'm going to rewrite this and factor out that 1/2, which is the coefficient of the x term. And if I take pi over 4 and divide it by 1/2, I get a pi over 2 plus 1. Okay. So my period of this graph is my normal period for sine divided by b, which is 1/2, which gives us 4 pi. My amplitude is the absolute value of that negative 2/3, so it's just 2/3. Never put negative there. My phase shift is pi over 2 to the right. My vertical shift, okay, that's the up and down movement determined by d, is up 1. And then I have a reflection because of this A is negative, and we have a reflection across the midline. So midline reflection. And the equation of the midline is y equals d, or y equals 1. All right, so pi over 2 pi, 3 pi over 2, 2 pi, 1, 2, 3. All right, so our midline is starting here for our parent function. We're doing sine, so we're on, above, on, below, on. There's one parent, that's my parent function, y equals sine of x. Okay, my period is 4 pi, so I'm going to count by 4 pi divided by 4, which is pi. So I'm going to label these tick marks pi, 2 pi, 3 pi, and 4 pi. Okay, I have an amplitude of 2/3, but I have a midline shift of 1, so I'm going to just count by 1. Okay, so first thing I want to do is I'm going to sketch my vertical shift up 1 by moving my midline up 1. Okay, then I've already dealt with the period by labeling those tick marks. So now I'm going to deal with my amplitude. So my amplitude means instead of everywhere I'm above or below the midline, I'm going to be 2/3. So I'm going to stay on the midline. Now I'm going to be 2/3 above the midline, then on the midline, 2/3 below the midline, and then on the midline. Okay, so that's my transformation there. My next color, I'm going to deal with my reflection. So reflection is everywhere it's not on the midline, it reflects over. Since there's a reflection across the midline, what's on the midline stays on the midline. So now we're down here, up here, and then up here, and then down here. So that's my reflection. And then as always, I'm going to do that phase shift last. And we're going to move over. And I'm going to do this one on my final graph, because I always put my last graph all by itself so it's easy to see my final picture. And this one I need to do 2 full periods, so I'm going to label my negatives. Okay, so for this final graph here, I have my midline at -1. Okay, and so my red graph is where I ended up because that was my reflection graph. So I ended here at, maybe I'll do it red so you can see. So I ended on the midline, and then I need to shift that to the right, pi over 2, which is half the distance. So this is just going to be shifted halfway, still on the midline. Then this at pi is going to be shifted halfway. And then on the midline at 2 pi is going to be shifted halfway. And then above the midline at 3 pi is going to be shifted halfway. That's not quite high enough. There you go. And then now on the midline again. Okay. And then above the midline, shift it halfway. Okay. On the midline, shift it halfway. Oh, that was too high. Shift it halfway. Okay. Below the midline, shift it halfway. On the midline, shift it halfway. And now you have 2 full periods of your graph. So this is the graph of y equals negative 2/3 sine of x over 2 minus pi over 4 plus 1. And now you know all the transformations of the sine and cosine graph.